Hey guys, welcome back. So in this second video, we're going to talk about law of sines and law of cosines. And those two formulas and relationships relate to triangles that aren't necessarily right triangles. We call those oblique triangles. So, what can we use to solve when triangles aren't right? Because that also happens in nature, right? That we don't have things that form perfect right angles. Okay, so today I'm literally just going to derive these for you. And that way you have a good sense of how these triangles relate to each other and where these formulas come from. Okay, so to do that, let's look at a general triangle. So in this triangle, I'm talking about triangle ABC. And that big triangle is not a right triangle. But what I have done in my triangle is I've dropped an altitude AD, which would form a right triangle, and I'm going to use that to help me solve. Okay, so if once I drop that, then this is like a height of my triangle, correct? And that height refers to, or this side is a relationship for this triangle, ABD, and it's also in a right triangle next door, ADC. Okay, so we're going to use those two relationships to create a proportion. So, okay, so this is what I did. I used angle B first and created a ratio using angle B and this side and this hypotenuse. So I used this side, which is little c. So I said that the sine of this angle should be the opposite, h, over this one's hypotenuse, c. Okay? And then I also used this angle in this triangle, c, so I did the sine of c equals its opposite, which is also that same h, over its hypotenuse, which in this case is little b. Okay, so what we notice here is that we have the same variable in both equations. This is a lot like that problem we did at the end of the last video. If you have the same variable in both equations, you can eliminate that variable. So then, as you can imagine, I'm going to multiply by the denominator in both, and I can then set them equal to each other because they'll both be equal to h. So this is what I mean. If I multiplied by c, I'd get c sine b equals h, and also if I multiplied by b, I'd get b sine c equals h. So both of these things are h. So that means I can set them equal to each other. So that's what I did here. I set these two things equal to each other, and then I divided both sides by c and both sides by b. So I did that so that I could have this relationship. So I literally divided both of them by c and b, but I just did it in one step. So then what I was able to see is that here the c's canceled, here the b's canceled, and I ended up with this relationship, which now I don't need the height to be able to do that. Notice C and B were the angles in the big triangle, and little c and little b were the big, like the sides in that big triangle. So I eliminated having to have that height. And so this is that law of cosines. And law of cosines says I could do the same thing to solve for the other relationship. I could use like another altitude. So like I also showed down there me using it with this as the height. And then that basically ends up giving you that the sine of A over little a, side A, is the same as sine B over B. And since these are all the same, like these both contain that, I could set them all equal to each other. So in general, this is your relationship for law of sines. So the sine of any angle, remember the angles are the capital letters, over its opposite side, that's the relationship, is equal to the sine of any other angle over its opposite side, and so on and so forth. So we use this the most when we're given two angles. So if we're given two angles in any side, it doesn't matter if the side is between or not. If you have at least two angles, you should be using law of sines. And then also if I have two sides and an unincluded angle, which is SSA or ASS, we'll talk about that. Producing ambiguous case, you can also use it. So you're going to learn more by trying this, and we can try one. Let's try one now. Let me insert a page here. Okay. So, for example, if I had, let's say we've got you and we've got, I don't know, a chicken. This is my best chicken today, I guess. There we go. It's a big chicken. Anyways, you and the chicken, you're both looking up into the sky, and maybe you spot a balloon flying away. And at the same exact second, you spot it, And so maybe the angle of elevation you see to the top of the balloon is maybe 54 degrees. And maybe the angle of elevation for the chicken is higher because he's closer. So maybe his is like 68 degrees. And we know the distance between you and the chicken, that's very crucial. You want to keep a certain distance from yourselves, is 100 feet. So notice I have two angles and a side. So we said whenever you have two angles, you can use law of sines to solve. So perhaps I can solve for anything else I want in the triangle. So maybe I want to know how far is it from me to the balloon, or you to the balloon, if you will. So this side. So this is where we can use our law of sines. So again, our law of sines says the sine of any angle over its opposite side. Well, the problem is right now you don't have an angle and its opposite side, but you do have two angles, which means you can get this third one. So that's what I would do. I would do 54 and I would add that with 68 and get what my missing angle from that 180 sum is. And so that missing angle is 58. Now, suddenly you have an angle and its opposite side. So that's where you're going to start. So you're going to say the sine of that angle, 58 degrees over its opposite side, is the same as, if I want to solve for this side, I need to use its opposite angle. So I'm going to say the sine of 68 over its opposite side, x. And guys, then you're just doing cross multiplying to solve. You can do that. If you want to use something that's a little different, you could also flip both sides, because this would still be true. So I could technically flip this and it would make it a little easier to solve, because then all I have to do is multiply by the sine of 68. You don't have to do it that way, but it's fun to explore different ways to solve. Either way, this is what you should be getting. So then I'm plugging that guy in. Again, I like to do that pre-made fraction. So I'm going to go alpha y equals, and I'm going to plug it in so that I don't have to use. So I can do it the order that I have it, sine of 68. Just make sure you close off that parentheses, because that 100 is not inside the angle. And then times the sine of 58, or sorry, divided by the sine of 58 on the bottom. So 109.3. So I'm about 109.3 feet from the balloon. And I could do the same thing to solve for this missing side. And then in the future, we're actually going to learn how to get the height of the balloon. I mean, well, you can do that. The future is now. We could get the height of the balloon at that exact moment. If we wanted that, now that we have this side and this angle, we can use regular old right triangle trig. So see that little triangle in there? Now you know this is 109.3, about. And this is 54, and you want the height. So now you could go, okay, opposite and hypotenuse. Opposite over hypotenuse is the sine ratio. So the sine of 54 equals this. Now, if you wanted to be really perfect, you would want to use this exact version of that decimal in here and then multiply. So like, I know I'm going to take what this was, which was about 109.3, and multiply it by the sine of 54. Again, if I want to be really exact though, I shouldn't use the rounded decimal. So what I could do in my calculator, I know that's the perfect decimal. So just take, so just take that guy. Does not want to like me today, guys. Just take that guy and that perfect one, and then multiply it by, what do we got? Sine of 54 it was. And it'll give you that, more exact answer of 88.45. About 88.4. So about 88 point, did I say 5.4 or 4.5? 4.5, so sorry, 88.5 feet. So there's the height of the balloon at that moment. So that's kind of stuff you're going to do with law of sines. Let's look at law of cosines. Okay, so in law of cosines, my little revealer guy is gone. I don't know where he went. There we go. Okay, so in law of cosines, I'm going to actually use the distance formula to help me get that. And I'm going to use this little figure here. So again, we're using this big triangle, which is oblique, meaning not a right triangle. In my drawing, I'm using variables. So like C is at 0, 0, obviously. B, which is out here, would be, A is the distance across from the angle A. So it would literally be on the x-axis. So that would be A in the x direction and 0 in the y. So that's where those two came from. The point A is a little bit harder to get. It's not terrible, but it is a little trickier to get because you have to use like this angle. and I have to drop the altitude. So when I drop this altitude, then I can use trig. So like to get A, I need this distance of that right triangle, and I need this y value. And so I just used the hypotenuse of that little triangle, B, to get that. Like, check it out. If I want this side, which is the x, I would use this angle, and I would use x and b. And adjacent and hypotenuse is cos. So I would say the cos of that angle, C, is equal to adjacent x over hypotenuse. But obviously, I just want the x, so then I would solve. So that's how I get b cos C equals x. And I could do the same thing for the y. So that's where that came from. Okay, so just so you know, that's how I got all those values. Okay, so now we are going to solve for a side, and I think we're solving for side C, yeah. So we're going to solve for side C by using the distance formula. So side C is this guy right here, and I'm going to use the distance formula. And I'm going to use the fact that this is a little right triangle, but you'll see how we can manipulate it in a little bit. So I'm going to use this. Okay, so I'm going to do my two sides of my triangle. So this side here would be all of that, and then minus this little part right here. Okay, so I'm going to do all of that side minus this little piece. This whole side, this distance all the way here is technically A, and then I'm going to subtract this little part so that I only get that. And that little part from here to here we just measured was B cos C. Now you might say, well, why in your formula did you do it the opposite way? I'm going to square it so it technically doesn't matter. So that I'm doing it this way because you'll see how nicely something works out in a moment. So like if I do 3 minus 4, I just get a negative number, but I'm going to square it so it won't matter because it'll come back out to the positive. I'm going to do the same thing for this side. But this side is easy because it's literally just that y value. I mean, the change there, the distance formula, is just this minus 0. So I don't even really need that, but I put it there to show you. Okay, and then remember, that would be equal to this side squared. So I had to do the square root. So there we go. So there's my basic formula for the length C. Now we're going to do some relations to kind of get it to where we want it. Okay, so that's that relationship. If I multiply all this out underneath, and notice I got rid of the square root by squaring both sides, so I changed that back to C squared. I multiplied this guy out, I did B cos C minus A times another B cos C minus A. Like that's how I got this stuff, guys. Okay, and then I just had to square this. Now be careful. When you take this, for example, times this, you get b times b, b squared, and then you have cos of c times cos of c, which is, we write that as cos of c, or cos squared of c. So that's where that's coming from. Just don't want anybody to be confused. Okay, and then, so that's that first part expanded. This is that second part squared because you weren't adding anything. Okay, so then what I did here, again, mathematicians took a lot of time to come up with this formula, so I'm just showing you, so it's okay if you're like, I couldn't have got that by myself. That's okay. We took a long time to develop these. So what I noticed is I have two terms that have b squared. So I grouped those together, and I took the b squared out of it. And then in addition, I had an a squared, and then I had this crazy term. So you guys should know from our studies in the last unit, if you have the cos squared of something plus the sine squared of something, we're familiar with that. That is a unit circle value. Cos squared plus sine squared always equals 1, the radius squared. So that's replaceable with a 1, which means 1 times b squared would just be b squared. So then we get this. This is the law of cosines relationship, but we usually, we can use it for any of the sides. So let's check out what this means. These are the other forms, but I'm not as worried about those. So I want to show you what I mean when I give you this formula. This is little c. This will be big C. These two other sides are A and B, and that's all you need. So when you're solving, first of all, the side you're solving for has to be opposite the angle you're going to use. So I actually refer to this a lot of times as the opposite side, and I refer to these two sides as your legs when I do my formula, because then I can use it for anybody. And then, of course, this is your angle. So your formula is set up like this. It says the opposite side from the angle, so I do this, opposite side from the angle squared is equal to my first leg squared plus my second leg squared minus 2 times the leg times the other leg times the cos of the angle that you're using. This is the formula that I memorize because then I can use it for any triangle. So again, opposite side from the angle you're using squared equals this leg squared plus that leg squared minus 2 times leg times cos of the angle, because this is a law of cosines. Notice I didn't ever have to use the height or anything like that of the triangle. I used the outer sides of the big triangle. So let's look at this together. Let's look at a formula, or I mean a scenario of this. So let's see, maybe perhaps we have like a lot of times, eventually, sometimes you'll do this stuff with navigation, but maybe I know that the distance from this town to this town was 50 miles. Maybe I know the distance from, and I'll call this, I don't know, town K, town M, town N. Okay, so the distance from K to M is 50 miles. Maybe the distance from M to N, town M to N, is only 37 miles. And perhaps I know that the angle between these two roads, if you will, is, I don't know, 108 degrees. Okay. And I want to know, all right, if I know the distance between these two towns, should be able to get the distance here. So this is what I'm looking for, the distance between, and I don't have to call it C, I guess I could just call it X. Okay. Using law of cosines is going to be best used, and I think I skipped this on the other page, sorry, if you have side angle sides, so two sides and the angle in between, or if you have all three sides. So we'll look at that one next. Okay, so the one that I'm solving for is opposite the angle I have. So this is my opposite side. So I'm going to have x squared equals, my two legs are 50 and 37. 50 squared plus 37 squared minus 2, don't forget that 2, times leg, times the cos of the angle across from it. Pretty easy stuff. Now be careful. I'm going to plug all this in. So that was 50 squared plus 37 squared minus 2 times 50 times 37 times the cos of 108. Okay, so that is what I get so far. But if you look at this and you write down that the distance between those two towns is about 5,000 miles, doesn't that seem a little crazy? Why is that crazy, guys? Yeah, this is for x squared. We have to square root that value. So be careful. Pay attention to the kind of answers that you're getting, right? Because they should make sense. That makes a little more sense, 70.8. So we'll say about 70.8 miles. Okay. Okay. All right, now that we have that, let's say, okay, now that we have this, we want to know what this angle is here. The angle between going to town N versus going to town M. This is where I can use the second version, which is I'm going to solve backwards. So you're going to use this as your angle. If this is my angle of reference, then the opposite side to that is now 37. So my opposite side squared is going to be the 37. My two legs, if I'm using this angle, are the 50 and the 70.8. And I'm just going to go ahead and use that rounded version. Minus 2 times those two legs times, this is all one term, times the cos of this angle, which is what I don't know. So your variable is here. So the first thing is I need to get these two guys on that side because this is all attached. In fact, you know what? I'm going to put the little minus here so that we don't get confused. So the first thing I'm going to do is actually bring over the 50 squared and the 70.8 squared. And that's equal to this, that's equal to negative 2 times 50 times 70 times cos theta. So now all of this is being multiplied, which means if I want to get rid of all of that, I have to divide. So I'm going to divide by negative 2 times 50 times 70. Notice I haven't done any of it because I want to keep it nice and perfect until the end. Now I'm going to figure out what this is. Again, I'm going to use my fraction, alpha y equals, and I'm just going to do everything right in order. 37 squared minus 50 squared minus 70.8 squared. Again, I know that's rounded, so it's going to be a little off, but it's not too bad. On the bottom, I have negative 2 times 50 times 70. Ooh, 70.8. Yikes, spikes. That was close. 70.8. Okay. That was close. All right. Now that is equal to this. But to get theta, I would have to take the cos inverse of both sides to get rid of that cosine. So that's my last step, is to just do the cos inverse of this. So second cos of my answer, boom, about 29.8. So about 29.8 degrees. And then once I have this, I can get this angle because they have to add up to 180. Okay. So that's how law of cosine kind of works in reverse if you want to get an angle. But to do that, you would have to know all three sides. So it's going to really depend on what you're given, which one of these laws you're using, right? So side angle side or side side side, you're using law of cosines. If you're given two angles, where'd it go? If you're given two angles or, yeah, if you're given two angles and a side, that's when you're going to use law of sines. So if you're given two angles, you should always be using law of sines. Or we'll talk about this SSA scenario in the next video. It's an ambiguous case possibility, meaning there could be two triangles. All right, guys. So now you are ready to continue on with your 20 of my nearest and dearest, and then the forced or one word problem packet. Okay, I'll see you in class.